Hello, my name's Dan Griffiths. I am a geologist and technical director for groundwater restoration with Parsons in Denver, and I'm the supervising contractor at the Lowry Landfill site. I prepared this presentation and I'm familiar with its contents and the site in general. In this presentation, I will provide a brief overview of the first half of 2024 Remedial Action and Operations and Maintenance Status Report, known as the Site Status Report or the SSR. This report contains site operational data and activities that occurred between January 1st and June 30th, 2024. First, some background information. The Lowry Landfill Superfund site is located northeast of the intersection of South Gun Club Road and East Quincy Avenue. Lowry is bordered on the north, northeast, and east sides by the currently operating Denver Arapahoe disposal site. The map on this slide shows the location of Lowry Landfill in relation to the surrounding roads and site features. Here we have a general timeline of the Lowry Landfill Superfund site and its journey through the Strickler Superfund site process. Lowry Landfill was added to the National Priorities List in 1984 and was closed in 1990. After closure, the Record of Decision was issued in 1994, and remedial design and implementation, which included the installation of all the remedial components we'll talk about in later slides, continued through 2006. Remedial construction was completed in 2006, and the site transitioned to remedy operations and maintenance at that time. The site has been in operations and maintenance and long-term monitoring since 2006 and will remain at this status for the foreseeable future. Since remedial construction was completed in 2006, site activities have focused on the operation and maintenance of the site remedial components, monitoring to ensure that the remedial components continue to operate correctly, and periodic reviews to ensure that the site remedy continues to protect people and the environment. The most recent 5-year review, finalized in January of 2022, found that the site remedy continues to be protective. The next 5-year review process will occur in 2026. Lowry Landfill was divided into 6 operable units during the remedial investigation, and this division was preserved through the remedy design and implementation process. Operable units, or OUs, at Lowry include OU1, shallow groundwater and subsurface liquids, OU2, landfill solids or solid materials disposed of in the landfill, OU3, landfill gas, OU4, which is natural soils beneath the landfill, OU5, which is stormwater and sediment in the ditches, and OU6, which is deep groundwater beneath the landfill. Each of these operable units were characterized during the RI and in some cases during follow-on work after the RI, and each OU is remedied and monitored routinely. The Lowry Landfill remedy is a containment remedy wherein the waste materials that were disposed of at the landfill during operation remain in place at the landfill and are contained by a series of remedy components so that they don't migrate out of the landfill. Containment is US EPA's presumptive remedy for municipal waste landfill Superfund sites nationwide and is not unique to Lowry. The remedial components all work together to make up the containment remedy at the Lowry landfill, and these remedy components consist of the landfill cap, groundwater and landfill leachate control, which is accomplished by subsurface barriers and pumping, the on-site treatment plant to treat water pumped out by the remedial pumping systems, the landfill gas collection system, and institutional controls. All of these remedial components are operated and maintained on a daily basis by a team of dedicated people on site. The operations and maintenance activities conducted on site are documented in the site status reports. These site status reports, or SSRs, are prepared every 6 months on behalf of the work settling defendants pursuant to subsection 2.1 of the Consent Decree Statement of Work. The SSR presented here is the most recent SSR in a long line of SSRs dating back to 2006. The SSRs are publicly available documents that can be downloaded on demand from the websites maintained by EPA, CDPHE, and Lowry Landfill. Simply Google Lowry Landfill and you'll be taken to these websites where SSRs and all other information regarding the site can be accessed. The current SSR summarizes all operations and maintenance activities completed between January 1st and June 30th, 2024. During the reporting period, operations and maintenance activities were conducted in association with the site water treatment plant, groundwater remedial action components, stormwater, landfill gas collection, and the landfill cover. No remedial action activities were performed during this reporting period. All operations and maintenance activities were conducted in accordance with 7 site plans listed here. We also have a set of separate plans defining monitoring activities that occur north or down gradient of the site. This slide presents key areas of the SSR that are summarized in the executive summary and are presented in detail in the body of the SSR document. And I'll use this as a guide for the rest of the presentation. We'll focus briefly on each subject, starting with remedy progress. Please note that the executive summary in this presentation only provide a very high-level overview of all the operations and maintenance work completed at Lowry during the reporting period. The SSR document contains an extensive presentation of all activities completed at Lowry during the reporting period and is a great reference for those interested in drilling into the details. This slide presents a list of groundwater remedial components that are evaluated in each SSR, as well as voluntary actions. Essentially, we look at each remedial component to determine if that component is working as it should and is meeting its objectives. The sum of all of these evaluations adds up to the determination that the remedy as a whole is working as designed. At this point in the presentation, we'll focus on the operations and monitoring activities that were conducted during the SSR reporting period. During the reporting period, the slurry wall, which is a vertical barrier that prevents groundwater flow into and out of the Lowry Landfill, continued to contain chemicals inside the eastern, southern, and western limits of the landfill. The North Toe extraction system continued to capture impacted groundwater flowing from the landfill toe. Also during the reporting period, the north boundary barrier wall, located at the north end of the site, continued to remove approximately 6 to 10 gallons per minute of groundwater and prevented contaminants from migrating off-site to the north. Groundwater extraction in the MW38 area continued to capture contaminated groundwater flowing through this area and prevented off-site migration. And vertical migration monitoring continued to show that contaminated groundwater has not migrated downward to deeper aquifers. At Lowry, more than 500 wells distributed on-site and off-site are routinely inspected and monitored to track remedy progress, and 7 active pumping systems are operated around the site to maintain groundwater capture. The 7 pumping systems are shown on this map to the right, along with the slurry wall shown as the red line going around the southwest, south, and southeast sides of Lowry. Regionally, groundwater flows from south to north around the Lowry landfill as indicated by the blue flow arrows. Along the length of the wall, there are a series of monitoring well transects consisting of 1 well inside the wall and 2 wells outside of the wall. The depth to the water table is monitored routinely in these well clusters, and maintaining a lower water table inside the wall, as shown in the example cross-section on the lower right side of the slide, indicates that the groundwater flow potential is inward and the water under the site is contained and flow outside of the site is prevented. Water table data collected during the reporting period shows that the monitoring system continues to be effective and the inward direction of groundwater flow was maintained and the containment objective is being achieved. Within the 500 or so monitoring wells on site, 60 wells located in key areas have been identified as compliance wells. Sampling at these 60 wells is conducted quarterly for 29 different indicator chemicals to monitor the performance of the groundwater remedy. During the reporting period, 52 wells were in compliance, in that concentrations of all indicator chemicals at these wells were below performance standards. 8 wells were out of compliance or potentially out of compliance, as indicated by the red dots on the map to the right of this slide. Additional response actions in the form of supplemental groundwater pumping continues at all 8 well locations in accordance with the groundwater monitoring plan to control or eliminate groundwater flow in these areas. The reasons for these out of compliance cases are understood and have been documented in other documents historically, and most recently in the effectiveness evaluations published in 2021 as part of the 5-year review process. During the reporting period, and historically, as reported in previous SSRs, public health is protected at and around the Lowry Landfill. In most cases, compliance wells are in compliance, and in the cases where compliance wells are out of compliance, groundwater flow is controlled through supplemental pumping. The impacted shallow groundwater is not being used, and the people in the environment are not being exposed. There are several areas that we want to focus on briefly during this presentation and that are presented in detail in the SSR. In this slide, I'm focusing on the North Toe extraction system, which is located in the approximate center of the Lowry Landfill. This system consists of a cutoff trench and groundwater pumping to capture groundwater flowing from the toe of the landfill. The performance indicator that is used to determine if this system is meeting its objectives is that the water table in the trench is maintained below the bottom of alluvium, thus capturing all groundwater flowing through this area. During the reporting period, the water level in the trench was maintained on average 6 to 8 feet below the bottom of the alluvium, and as you can see in the map in the top right part of this slide, groundwater flow is towards the trench. Thus, the North Toe extraction system operated as designed during the reporting period and achieved its objectives. In this slide, we're taking a look at the north boundary barrier wall, located on the north side of Lowry. We've talked about this area many times during past public meetings, as this area is a key component to the groundwater containment remedy. On this map, the north boundary barrier wall is shown as the green hatched polygon, and the pumping wells around the north boundary barrier wall are shown as the purple dots. The blue lines on this map are groundwater potentiometric surface lines that depict the shape of the water table in this area. As in past maps of this area, there are low spots around the pumping wells. The red arrows you see show the direction of groundwater flow, and the yellow shaded area is the area of containment that is maintained by groundwater pumping. Any contaminants in the area of containment are contained and will eventually be removed by the pumping wells. The crosshatch areas denote dry areas or areas where the weathered Dawson has been completely dewatered. Groundwater is not flowing and contaminants cannot migrate through these dry areas. This map is figure 417 in the SSR, and I invite anyone who's interested to take a look at the SSR for more detail on this area. On this slide, you see the MW38 sand channel area located on the northwest corner of the site. Much like the last slide, the blue lines are potentiometric surface contours that depict the shape of the water table in this area. Extraction wells are shown as red dots, and the compliance well in this area is shown as the blue dot. The blue arrow is pointing to the compliance well. Red arrows on the map show the direction of groundwater flow. As you can see, the groundwater flow is inward toward the sand channel, depicted in purple, which is the primary objective of the MW38 pumping system. The chart on the left side of the slide shows contaminant concentrations measured in groundwater at the compliance well, and as you can see, contaminant concentrations continue to decline. The time scale shown is about 17 years. As in the case of the previous slide, the graphics on this slide are directly from the SSR, and if anyone is interested in more detail, they can get that from the SSR document. And the final groundwater remedy component we wanted to highlight is the north end response action pumping. This groundwater extraction occurs in the weathered Dawson water table aquifer north of the north boundary barrier wall we looked at a couple slides ago and south of Yale. So on the map you see to the right, the top of the map is Yale and the bottom is the north boundary barrier wall. There are 5 pumping areas, 16 extraction wells, and a series of monitoring wells in this area, and groundwater samples are collected quarterly to monitor groundwater quality. And on this slide, we have depicted 1,4-dioxane concentrations in groundwater north of Yale and south of Mississippi. The response action objectives for the pumping south of Yale is to remove 1,4-dioxane mass from the plume, which has been achieved during the reporting period, as shown with about 6.7 million gallons of groundwater removed and about 0.5 pounds of 1,4-dioxane extracted. In addition, groundwater monitoring in the north end continues to document declining 1,4-dioxane concentrations as reported in the SSR. The data plots on this map are examples of data plots available in the SSR that are there to show 1,4-dioxane concentrations over time, which are all downward, meaning that the 1,4-dioxane concentrations are going down and water quality is improving. If anyone's interested in digging into this further, all of this information, the map, and all of the plots are available in the SSR. During the reporting period, and historically, as reported in previous SSRs, public health is protected north of the Lowry Landfill. The groundwater in the shallow groundwater plume north of the site is not being used. There are no drinking water or agricultural wells installed in the plume footprint, and the plume is getting smaller over time. People in the environment are not being exposed to the remaining contaminants in the north end plume, as the plume is being remediated. And to complete the groundwater story at Lowry, we have some information on the treatment plant itself. The treatment plant receives and treats groundwater pumped by the groundwater pumping remedy components we've already discussed. We treated approximately 1.5 million gallons of water during the reporting period using the biological treatment system and advanced oxidation. The combination of the two systems destroyed more than 92% of the incoming contaminants and discharged water to the Metro sewer system in compliance with our discharge standards. We have a third system, the ion exchange system, that we installed in 2021 that removes about 97% of the molybdenum from the water coming into the plant. The ion exchange system is a sorptive system that removes the molybdenum from the water stream by absorbing it onto the ion exchange media. The media is then removed from the system and disposed of off-site. After the treated water is discharged, it goes to Metro's water treatment plant for further treatment before it is eventually discharged. The on-site plant removes or destroys all site chemicals to meet safe standards before the water leaves the site, and the treatment processes we use leave minimal environmental footprints. The treatment plant has met all discharge standards continuously for more than 20 years, and the plant team won the Metro Water Recovery Gold Award every year for the last 5 years. Now let's depart from groundwater and talk briefly about the other remedial components that are maintained and operated on site. First, we have the landfill gas collection system. The waste at the landfill is covered and contained, so gases generated through the degradation of the contained waste need to be extracted and collected to maintain containment. The gas collection system consists of 64 gas extraction wells, condensate traps, piping, 2 flares, and the gas-to-energy plant. This system removes about 5,000 tons of methane each year and produces enough electricity to supply power to about 2,500 homes in the area. During the reporting period, this system was maintained and operated successfully. More information on the gas collection system is presented in Appendix D of the SSR document. As mentioned in the previous slide, the landfill is covered with a layer of compacted clay and soil about 4 to 12 feet thick. This cover reduces the infiltration of rain and snowmelt into the landfill, minimizing potential for groundwater impacts. During the course of the reporting period, the cover was routinely monitored to look for settlement or any other issues. Settlement of landfills is normal and occurs gradually as the waste materials in the landfill degrade over time. Small areas of minor settlement were identified and filled, and then seeded with native grasses in the first half of 2024. And the last remedy component is stormwater monitoring. During the first half of 2024, a storm event that was big enough to get stormwater to flow on site occurred on April 27th, and a stormwater sample was collected. The results of that sample are shown in this slide and are included in the SSR on page 61. If you have any questions or want additional information that can't be found in the various site documents, please address your questions to the US EPA Community Involvement Coordinator, Brent Campbell, at the email address on this slide. And this concludes this presentation on the first half of 2024 Lowry SSR. I hope you enjoyed this presentation and you take a look at the SSR document to learn more about Lowry Landfill.